The first thing we do is we model each polynomial. So this guy has 3 big guys, unshaded, 2 bars, unshaded, and 6 little guys, shaded. This guy has 1 big guy, shaded, 2 bars, shaded, and 1 little guy, unshaded. Now I group the matching tiles. So this guy goes here. This guy goes here. I forgot the bar. What the halibut? Oh, it's screwing up on me.
I got another joke for you.
Go ahead.
Why the fish chase after the boat?
Why?
Just for the halibut.
I know that one. I just needed to think about it. Just for the hell of it, halibut.
Oh, not funny.
All right, so this guy moves over here, and then this guy would move over here, and we would remove our 0 pairs. So we've got 2 big guys, 0, and 5 little guys, yeah? So that's what was remaining. What do they represent? 2x squared minus 5. Oh, it was s, yeah. Right?
Yeah.
Now, that's the first part. The addition sentence is everything. 3s squared plus 2s minus 6 plus negative s squared minus 2s plus 1 equals 2s squared minus 5. An addition sentence has both a question and an answer, because just like in English, a sentence is a complete thought. Okay? Technically, it's an independent clause, but, you know. So, you guys go ahead and do these. 6 bars. 4 little guys. 2 bars shaded. 1 little guy. Do the grouping. Takes 2 seconds to do. If you can count, you can add polynomials. Okay? Everybody good? Now I want you to forget about algebra tiles till your test. Okay? Well, we're going to have to use them one more time, because like I said, they actually do have one use. When it is. Look on the outline. What are we doing right now? Adding. Then we'll do subtracting. Then you'll have a quiz. Step 1. Remove the brackets. So they're all gone. So I get 3c squared plus 5c minus 6 plus 2c squared minus 3c plus 4. Now it says group like terms. Remember we talked about like terms yesterday. What makes something a like term? Same same variable and
Degree.
same degree. Right? Now, a lot of people say same exponent, but you don't want to do that because then you look at the exponents, right? And some of you, none of you guys, because you're the honors class, but you might add 2x squared and 2x squared z because you're only looking at exponents. Okay? So be careful with that. So now when I say group, do you actually have to rewrite it? Of course not. Yesterday, what did I do? I highlighted them. Today in the warm-up, I said I'm starting with the c squareds, and I just looked for other c squareds, and I did that. 3 and 2 is
5c squared.
5c squared, then they're gone. 5c minus 3c
2c
plus 2c, and they're gone.
minus 2.
And negative 6 plus 4 is negative 2. Aight? Aight. Oh, wait a second. Let's have a little fun here.
Oh, that was a spider for a second, so.
Yeah, that totally looks like spider.
What?
Dig down there. Looks like you.
I look like a carrot.
Draw a little bunny. Draw
I'm not done.
What's that?
Yeah, bunny. Why is the bunny? Why is the carrot larger than the bunny? It's a big carrot. Yeah, that's why the bunny's so high or something. Yeah, the bunny shaped animal.
Oh.
Hey, those are sweet guys.
I know. It's Halloween.
Look at the bunny, a pink little nose. Killer bunny. It's a killer bunny from Monty Python and the Holy Grail. Oh my God.
Yo.
You never, remember when you asked us that question? Why it's 6 over the polynomial?
No. It's not.
Why not?
Because it has a variable in the denominator.
Yeah, it's variable in the denominator. Good. All right. So this is done. 7 plus 3. 10. Negative 8 plus 1. Negative 7. So what's the answer? 10g minus 7. This one? 3c squared. They're gone. Plus 11c, because there's no other c's. It's gone. Okay? Everybody good?
Yeah.
Okay. Now, this is another way to do it that as you get to bigger and bigger polynomials, this becomes a really useful method. I, of course, as always, show you it with a super simple method because the method doesn't change, right? It doesn't matter how easy the question is. If you follow the same method, it'll always work. And because I don't want you guys to write out a million things, you don't really need to write out. So, if we have big polynomials that we are simplifying, this vertical method is kind of helpful so you don't miss out on one of the terms. Okay? So, start with 1, 3m squared plus m minus 14. Spread them out a little bit. Then, that guy's taken care of. Now we go to this guy. I got a positive 2m. Where does that go?
They're actually going to...
With the m's. So I got a positive 2m, and I had a positive 9. Then I just add them up the way you were taught to add in grade 3. 3m squared plus nothing more is 3m squared. 1m and another 2m's is 3m's. And negative 14 plus 9 is negative 5. And again, it's not that it's difficult. Don't get me wrong, because it isn't. This is the method. Just like 3 plus 4 is 7 is no different than 8.3759 plus 2.751 plus 8.36927. It's the same principle, right?
Yeah.
One you can do in your head, one you need a calculator or paper to do. But you're going to do the same thing. Yeah? Yeah. So we start easy, so we have the tools to apply to a more complicated situation. So how am I going to rewrite this? 2x, then some space, 4x plus 8, and I'm going to get what? 11. Easy peasy lemon squeezy. 5p squared. Now, I'm going to leave a space because there's a p there, but I don't need to. Plus 12. Negative 2p squared. Plus 3p minus 7. 3p squared plus 3p plus 5. Gouda?
Great.
Great. And that's it for adding. Does everybody feel they can add?
Yeah.
Excellent. Now, subtraction screws everybody up. And like I said, this is really the only use that I have for algebra tiles that I have found. They're actually helpful here. So, remember, it's a two-part process. There's modeling, and then there's the subtraction sentence. So let's model it first. 3b squared minus 2b minus 1. Now, don't do the shortcut here. There's a reason I don't want you to do the shortcut, okay? We're actually going to draw it out. 3 big guys. Agreed? Okay. 2 bars, shaded. Agreed? And 1 little guy, shaded. Agreed? Okay. Now, subtract. What do we say when we're subtracting? What's the grade 3 words that we use for it? No. I wish it was that. Take away. Right? Just like, how do you say this expression? 3 times 8. And then if I ask you, what would go here? And some of you would say, well, I got to times 3 to get 8. Or times 3 by 8 to get 24. No, the proper word is multiply. So we use take away from grade 3, right? So do that here. Take them away. I need to take away 2 big black squares. Where are they? Exactly. Where are they?
Right there.
Where?
Right there.
Where? I see 3 white squares. I see 2 black bars.
Inside.
And I see 1 black little one. How am I going to take away that when they're not there?
0.
What do you do, Leighton?
You use 0.
You use 0 pairs. What? What are you talking about? That's crazy talk.
It's just 3 minus 2.
No, it isn't. If it was that, it would be easy. You're wrong. How much did I just add there? I added 0, didn't I? Because that's 0 and that's 0, correct?
Yeah.
Now, do I still have 3b squareds?
Yes.
I do, because this is 0 down here, isn't there?
Yeah.
Now, can I take away 2 big black ones? Where? They can disappear. That was really anticlimactic. Got it? Now, can I take away 1 black bar? Oh yeah, because he's already there. So that guy can disappear.
That's 3 minus minus.
Can I take away this guy?
Okay, how am I supposed to do
And
that?
2. No,
Just
you
wait.
can't.
Can I?
Well, you can, but.
Not right now. There is no unshaded boxes there. So I got to add 0. Now, can I take away 2?
Yeah.
And what's my answer?
Plot.
What do you see?
5
5b squared
B squared minus
B
minus 3.
What? 3.
Now, as I have said before, this is the only use I can find for algebra tiles, because it shows you why this works. Now, Leighton just said, Mr. Myers, how do we draw that? So I'm going to go back to what I had before. I had this. Right? Right?
Yeah.
I can't take them away. So I got to add my 0 pairs, which was 1 pair, 2 pairs. Didn't need it there. Needed it there. Right? Now, take them away. What's being taken away? This guy, this guy, and this guy are gone, correct? And this guy are gone, correct? Leaving me with 1, 2, 3, 4, 5.
Oh, it's gone.
Yeah, I'll fix it in a sec. And this guy is gone. Now, what is left? We have the answer. What's the subtraction sentence? 3b squared minus 2b minus 1 minus negative 2b squared minus b plus 2. Now, who can tell me why I think that this is the only use for algebra tiles? Jack.
Because this other addition we can easily do, is this one kind of works algebra tiles because it's like very tight, but.
You are actually on the right track.
Wow.
3 minus 5. What is it? Negative 2. Negative 3 minus 5. Negative 8. Negative 3 minus 5. Positive 2. Can any of you explain why that is? Or do you remember a grade 7 teacher saying adding a negative or subtracting a negative is the same as adding a positive? That's what you remember, don't you?
Yeah.
Which is real useful when? Everywhere that you can remember that pointless fact, right?
Yeah.
How many of you, and there'll be few in here, but there will be some of you, that if I said, I'm going to write 10 questions up here and it's going to be a race, and I put in a few of them, I know that some of you would write negative 8 there. You say that you wouldn't, but I know that you would, because I have been teaching for 17 years. And I know that some of you, in your race to be first, will screw that up, because you have not actually learned why. Now again, I say algebra tiles have one use. It is this, negative 3. 1, 2, 3. Yes?
Yeah.
Take away negative 5. Are they there? No. 1, 2, 1, 2. Now can I take away negative 5? What am I left with? Positive 2. That is why algebra tiles have a use, in my mind. It's the only way to explain this. that I have found, except to say adding a negative, subtracting a negative is the same as adding a positive, which is completely useless. You need to know why things work. If all the universe was facts, then we'd be in big trouble, wouldn't we? Right? You have to know how to do something, not what it is you're doing. Sam.
I don't get it. How do you just add like the two negatives and the two?
What did I start with, Sam?
You got it with the negative 3.
I started with what? Negative 3, right?
Yeah.
How much is this? 0. How much is this?
0.
So I started with negative 3 and then I added 0 twice. How much do I have? Still have 3, don't I? But now I have the 5 negatives I need to do take away negative 5.
What if you added another like 0 pair? If you had like another 0?
Well, then I would add another 0 pair, and I would only need to take away 5, wouldn't I? So these 5 disappear,
Oh, okay.
leaving me with 1, 2, plus what?
0.
And what's 2 plus 0?
2.
2. And isn't that the answer to this problem? Okay?
So it doesn't matter as long as you have 2 0 pairs. Or enough.
You have to get enough, you have to add enough 0 pairs to cover what you need to remove. Everybody cool?
Yeah.
So let's look at this next one, and we're only going to do it twice, then we're going to be done. I've got 4 big guys, 4 bars shaded, unshaded, 3 unshaded little guys. What must I remove? I have to take away 2 big bars. So this guy's losing 2, leaving me with 2 bars, yes?
Yeah.
This guy's losing what?
1.
1, leaving me with 1 little guy. So what's the answer? 2p plus 1. Got it?
Yeah.
I'm sorry, plus 2. Everybody good? 3 minus 1. Yeah?
Yeah.
All right, now look at the next one. I got 5 bars, positive, and 1 little guy. I have to remove 2 negatives. Are there any there?
No.
No. So I got to add some zeros. I got to add 2 negatives and 2 positives, don't I?
Yeah.
Still have 5. Now, can I take those away?
Yes.
I can take those away, leaving me with 7 bars.
7.
Now, I also got to take away 3 positives. Do I have that?
No.
No. So I add 0, yes?
Yeah.
Take away the 3, and what am I left with?
Nothing. Negative.
2 little guys that are shaded, which is 7t minus 2. Good?
Yep.
And again, this is really only useful to explain how addition and subtraction work with negatives. Now, what bothers me as a senior math teacher is many of you have never seen this. Many of you, your experience with negative numbers is your teacher telling you some facts. Right? Subtracting a negative is the same as adding a positive. Subtracting a positive is the same as subtraction. Blah, blah, blah. All these rules. That explains every single rule in one shot. But people don't use them. They wait until grade 9 and 10 to use them when they're pretty useless. Everybody cool? Okay, forget about it till a test. Because now we're going to do real math.
Yeah.
What? No. 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 All right. We are going to do this symbolically. What does that mean? We're only going to use numbers, okay? Here are the rules. 1, remove the brackets from the first term. So what do I write? Negative 5k squared plus 2k minus 6.
Oh, there's a catch.
What is it?
Because it says minus and then bracket, actually there's a -1 inside or each of them. And so it actually multiplies with each of them, and then it turns opposite.
What truly is subtraction? Adding the opposite. So what do I really do here? Plus all the opposites. What is the opposite of 3k? Negative 3k squared. What is the opposite of negative 4? Plus 4k minus 1. Now, that's the opening salvo, which is a $5 word for the opening shots. Amshman has gone one step further because technically, what lives right there?
A 1.
That is technically a 1, because that would be 1 times everything in there, wouldn't it?
Yes.
And that 1 would have to go to everything. And since he's negative, that negative 1 would turn this positive 3k squared minus 4k plus 1 into negative 3k squared minus 4 plus 4k minus 1. That's interesting. Well, no, it just disappeared. It's because my computer sucks and it's stupid. Because I needed a new one instead of the old one that worked just fine. Christ. Whatever. So we're going to add the opposite. So we had negative 5k squared plus 2k minus 6, and we add the opposite. Negative 3k squared plus 4k minus 1. And then it's just what we already know how to do, right?
Yeah.
Negative 5, and then negative 3 more. Negative 8k squared. Done.
Plus 6k.
2k plus 4k more. 6k, done.
Minus 7.
Negative 7, and then negative 1 more, negative 7. Gouda? Great. Remember, this stuff over here is there to help focus your thinking. Because I hope most of you recognize that your first quiz here is going to be no calculator. That's to focus your thinking. Use it, don't use it, I don't care. That's totally up to you. But do your work. So, 8f minus 3. As soon as I see a negative, I'm adding opposites. Negative 7f minus 5. 8 minus 7, f, negative 3, and then negative 5 more, negative 8. Here, what's weird about here?
It's not in order.
It's not in order, which is why I gave you this handy-dandy little clue out here to remember to write it properly. So what should I start with? You could rewrite, or you could just work out of your head, right?
Yeah.
If you're going to rewrite, which is what I'm going to do, because the more work you show, the better. Plus, but I'm going to switch this around now, 4g squared minus 9g minus 2. 7g squared negative plus 4?
Minus 3g squared.
Minus 3g squared. Done. 5g minus 9g
Minus 4g.
minus 4g. Done. And 2 minus 2? Gone. Done diddly-un. Cool in the Gang? Cool in the Gang was a band from the 80s. They sang, "Celebrate good times." Come on!
I want a radio plug for that song.
You know that song?
Yeah.
Yeah, of course you do. It's a celebration. We gon' celebrate and have a good time. Celebration time. Come on! Let's all celebrate and have a good time. There's a party going on right here. A celebration to last through all the years. So bring your good times and your laughter too. We gonna celebrate your party with you. Come on now. Celebration. The only reason I say it is because one of my favorite movies ever, one of the guys in it says, one guy says to him something, I don't care, I don't even remember what it was. And the cool guy says, Kool and the Gang. And I've been saying it ever since 1994. I even have a picture on my phone of the band Kool and the Gang. So if someone sends me a text that I think is cool, I send them back the picture of Kool and the Gang. I also have a picture of Coolio if I want to mix it up a little.
What's Coolio?
He was a bad rapper from the 90s. So I sent my wife a picture of Coolio. She said, I'll be there to pick you up in a little while. So I sent her a picture of Coolio. And she's like, what the hell is that? So then later that night, I sent her a text that said I loved her. And she sent me back a picture of the band U2.
Oh my God.
I want to start doing more of it now, right? Like, oh, I'm so itchy. And send her a picture of the Beatles because there's bugs. Something like that. All right. Are we good? Oh, that was all recording. Excellent. Oh, well.